Hello class, today we are going to talk about section 1.7, which is about algebraic functions. At the end of the lesson, you will be able to identify if a relation, remember that's a set of ordered pairs, you'll be able to identify if that relation is a function, and you will be able to calculate function values. A function is a specific type of relation where each input has one output. So that means each x is paired up with a unique y. This allows us to have the y values repeated. So 2 can get paired with 3 and 5 can get paired with 3. But we would not be able to have this set of 3 numbers. It's okay that 2 is paired with 3 and 5 is paired with 3, but the problem with this is 2 is also paired with 4. In order for it to be a relation, it means every time you put in 2, you have to get out an answer of 3. There are 2 different types of functions, discrete functions and continuous functions. Discrete functions are ones where the points are not connected on the graph. If you look at the 3 examples at the bottom, the left example is a discrete function because those points are not connected. Continuous functions means that the points on the graph are connected. So the middle one and the one on the right are both examples of continuous functions. As you can see, those continuous functions do not look the same, and that is because there are 2 types of continuous functions. First, there's a linear function. That is where the exponent on all of the variables are 1. That's going to give us that straight line that you see in the middle example. The other type is nonlinear functions. We group all of those together if there is an exponent of something other than 1. It doesn't matter if it's 2, 1.5, -3. As long as the exponent is not 1, it is going to give us a nonlinear function. That example on the right is just one type of nonlinear functions. They can give us many different curves on a graph. This is just one example. Last piece of vocab for you today is function notation. This is a special way to write out equations that are functions. Normally, what you would see is it written out with 2 variable format. So our x is our input and our y as our answer. When we are looking at function notation, the x is still the input, but this output part is written as f of x. What this is saying is we have function, which we are calling f, with variable x. So that's saying you have one equation, which we're going to call equation f, and the variable or the independent thing that you are plugging in for is x. You would still plug in for x and get an answer the same way. Instead, the first one would say y is equal to whatever your answer is, and the second one says f of x is equal to whatever your answer is. One of the ways that we can identify a function is using the vertical line test, or another thing that it can be called is the pencil test. This is using a vertical line or a vertical object to decide if the graph intersects the line more than once. So what you would do is you would either draw in or visualize a bunch of vertical lines being drawn on the graph. Then you are seeing if your actual function hits any of those lines more than once. So all of the purple points that I just put in, each of those hit the line only once. These 2 on the end are not hit at all. That's okay because it still is not hit more than once. So this particular graph is a function. If I draw in those vertical lines onto my second graph, the first 3 lines are fine because they don't get hit. This 4th line is also okay because it only gets hit once. The next line is not okay because the vertical line is touched by two different places on the graph. So this is an example of a relation that is not a function. It gets hit twice on this same vertical line. The last one is a little bit tricky. If I draw in my vertical lines, it looks like this fourth line gets hit twice. But the one catch on this is if you notice that top circle is an open circle, this is actually okay. This open circle right here means that that's not actually a point on the graph. It's not something you're really going to have to worry about with in Algebra 1, but they just want you to be able to recognize that if one of the two circles that hits, or one of the 2 points that it hits, is an open circle, it is okay and it is the function. That is the one catch with this particular test. Other ways to identify functions besides the vertical line test include being able to look at equations, mappings, sets of points, or a table. So if you are looking at an equation, you are looking to see if each x is going to give you a unique answer for y. One of the best ways to do this is just start testing points. So if I plug in 1 for x, I get 4 times 1 is equal to y plus 8. So that means something plus 8 is going to have to give me an answer of 4, and our answer is -4. So when I plug in 1 for x, I get an answer of -4 for y. The next thing I would check is 2. So I get 8 is equal to y plus 8. That gives me y is equal to 0. And then I would check 3. 3 times 4 is 12 is equal to something plus 8. That is giving me an answer of +4. You could keep going and plugging in more numbers, but you would find that none of your y values are going to repeat. So this is an example of a function. When you are looking at a mapping, you are looking to make sure that each point in the domain is going to exactly one y value. So for example, -2 is going to -3. That's fine. 0 is only going to 6. That's okay. 3 is also going to 6. That's okay. We can repeat the y values. We cannot repeat the x values. 4 is only going to 9. So this is an example of a function because each x only gets paired with one y. If I, for example, had another line, that blue line in there, that had -2 pointing to -3 and +6, then it would not be a function because -2 would be going to 2 separate values. So go ahead on these last two, check to make sure that each x is only getting paired with exactly one y. So tell me if they are a function or not a function. So this first example is a function. Each of our x values is paired with exactly one y value. There was no repeats within the x. The second one is not a function. If you look at this first one, x of 4 gets paired with y of -4. Or excuse me, x of 1 gets paired with y of 4. The last value has x of 1 getting paired with y of -4. So same x, different y means that it's not a function. The other thing that we are going to do today is calculate function values. This means that we are plugging in a number in the place of x, or in the place of our variable, to solve. So our function is f of x is equal to -4x plus 7. The first thing they want us to solve is f of 3. So what this means is that 3 is getting plugged anywhere we see x in the equation. So I would say f of 3 is equal to -4 times 3 plus 7. f of 3 then is equal to negative 12 plus 7, giving us a final answer of negative 5. So f of 3 is equal to negative 5. That's saying when I plug 3 into function f, I get an answer of negative 5. Looking at the second one, it's slightly different. We have this plus 1 on the outside of the parentheses. So what's going to happen is we're going to say f of 2 plus 1, you always copy down exactly what they give you, is going to equal, we're going to plug in 2 wherever we see x. So negative 4 times 2 plus 7. That's f of 2. But we also need to add plus 1 on the end. So when that extra piece is outside of the parentheses, you still have to add it on the end. So f of 2 plus 1 is equal to negative 8 plus 7 plus 1. Negative 8 plus 7 plus 1 gives us f of 2 plus 1 is equal to 0. So you are just plugging in and following the steps of PEMDAS. Go ahead and try these two on your own. F of 3 in this case gives you negative 39, and f of 4 plus 1 gives you positive 46. Last thing we're going to talk about is if there is some multiplication involved and if I'm plugging in a variable in the place of another variable. So, first thing we're going to talk about is f of m, which would mean I'm plugging the letter m into wherever I see an x. So I'd have 12m minus 3 now. The other thing that this question asks us to do is multiply everything by 3. So I would do the same thing on the other side and multiply by 3. This turns it into a distributive property, so I end up with 3 f of m is equal to 36m minus 9. If you have questions about this or anything else from the lesson, please let me know when you get to class.